Hello friends, welcome to the second session of Advanced Solar Photovoltaic Designing. The name of the session is Understanding the PVSys software. So what is need to be done to understand the PVSys software? What PVSys software do? And why it is required? Okay. So the PVSys softwares basically do two basic operations. The first operation what the PVSys software do is to do the simulation. Simulation using three basic parameters. First is the parameter of the solar radiation available. Second, what PV modules you are using, component 1. And then third, what inverters you are using, modules, inverters and radiation. These are the three basic parameters of PV system. And these are the three basic parameters of any solar photovoltaic designing. Okay. So then you can ask me question, sir, means what you, if I tell you that this is the software, this is the module I am using, this is the inverter I am using, and this is my location, and that's it. So I would like to say yes, that's it. Okay. When you go deep into it, then the PVSys will do a lot of deep insider calculation also. The first insider calculation PVSys do, they will ask you to input is that how you are gonna connect all these PV modules. Suppose there is a 5 megawatt power plant. One PV module is of 250 watt peak. Okay, 5 megawatt means 5 million watt peak. Okay, one module is 250, so 5 million divided by 250 is like 200,000 modules, 20,000 modules, right? So there are 20,000 modules. So how you're gonna connect? How many modules you connect in series, and then how other modules you need to connect in parallel? So the modules connected in series is called string, and the modules connected in parallel is called arrays. So how many modules you want to connect in series? Is there any thumb rule? Okay. So yes, there is a thumb rule. Number of modules you can connect in series, because series the current is same, but the voltage costs add up. Okay. So every module have a voltage and the current, like VOC and ISC, open circuit voltage and short circuit current. That is the maximum voltage that a module can produce and the maximum current the module can pass through. So if the VOC of all the connected series connected modules crosses 1000 volt, it is not good for designing. It should be less. So that's why number of modules connected should be about 22, 24, 16, 18. It depends upon what is the model. Okay. Second thing is, when you decided that how many modules you want to connect in series, then you need to decide that you want to have string inverter or central inverter. String inverters are small inverters, 50 kilowatt, 60 kilowatt, 100 kilowatt. Central inverters are big, 1 megawatt, 1.5 megawatt. Let's say 5 megawatt plant, you want only 5 inverters, that's it. But string inverters are more effective because they are small, easy to install, easy to maintain. So which string inverter you want to use, you can choose from the list, 50, 60, 100 kilowatt, 250 kilowatt, up to you. So that's it. Inverter selection, module selection and site selection. That's what is required. When you do the simulation in PVSYST and you find out the losses analysis, then in the losses analysis I will tell you that how PVSYST calculate those losses and how can, that is the next session I will tell you, session 3. Now let's do on the PVSYST. So we open the PVSYST software here. Yes, the PVSYST software is in trial mode, so please, no issue in that because you are here to learn only. Close this box. Step by step procedure. Welcome to PVSYST 7.2. Project design simulation. Grid connected, standalone, pumping, measured data, tools, database. So first thing you need to do is to do in the data, go into the database. In that database, see, there are three basic things. Meteor database. Meteor means meteorological, means the climatic kind of data. Second thing, main components are PV modules and the grid inverters. Battery we are not using, and other things are not important. Generators, controllers, standalone pumps, no. PV modules, inverters, and the meteor database. Now let's go to the geographical sites for the sites available. Suppose we want to add New Delhi. See, we clicked on import. So this New Delhi site is, they are importing the New Delhi Safdarjung site. Okay. Now let's see the radiation. Global horizontal irradiance. Global horizontal irradiance is the name of solar radiation what we are using, what we are measuring. Why it's a global horizontal? If we put a horizontal plate on the ground, how much radiation is falling on that ground horizontal plate? That is called global horizontal irradiance. And what is their unit you are using? As I told you, kilowatt hour per meter square per month. So every month how much is the kilowatt hour is there? So yearly 1957 kilowatt hour per meter square per month. Okay, this is how much they are using. Okay, save. So Delhi format is already saved, right? Now let's talk about PV modules. So there are so many PV modules already there. So let's just close it because we are going to use anything between 300 watt peak to 440 watt peak, any PV module. Grid inverters, there are major generic grid inverters are there. 500 kilowatt, 60 kilowatt string inverters. We can use any inverter whatever we want as per our size of the plant. Okay, so this database is done. Now let's go to the grid connected. Project name, new project, no problem. You can put the client name. Mutio file, you can check the database. Current geographical site is already there. Hello guys, we selected the meteor file of New Delhi. When you select the meteor file, there is two big box came here: orientation system, horizon and near shadings. So we need to go to the orientation. Orientation means how your modules are oriented, tilt. Okay, so if it is a plane tilt, we can just make it as a plane tilt of 29-30 degree. We tilt the modules as per the latitude. Azimuth 0 degree. Why 0 degree? Because we want our panels to look into the south facing panels. That's why we need to make it azimuth at 0 degree, because we are in northern hemisphere and the sun rises from east to west. Okay, so if we face ourselves towards the equator, then we can have the more picture of the sun. The panels will have more picture of the sun. So that is the orientation is done. Now the system, simple, right? Name PV array. So you need to select one module. So we selected the module of 300. Okay, now we need to select the inverters. Okay, before we select the module inverter, we need to select the planned power. How much power we need to set up, or how much area we have. Suppose we have a lot of area and we need to do a power of 200 kilowatt, 250 kilowatt peak. This is the planned power. So module we already selected. Let's select the inverters. Yes, so we selected 60 kilowatt inverters for 250 watt peak, and so it's already giving you that 19 to 35 modules in series, number of string 25, and inverters use 188 kilowatt. Okay, so its number of inverters 4 and 33 modules should have, right? Okay, modules inverters string is 33 modules per string. Okay, click run for the simulation. The simulation is done. Very good. Now save it, save, and let's go to the report. So this is the report we just generated. See, it's a very simple. This whole PV system is a very simple exercise, right? Let's save the report on desktop. Report. Okay, so now you can find out that, see how simple the PV system is. Okay, how simple the PV system is. It's not so difficult as a software. The only requirement is you should know is the meteor file, the location, the inverters and the modules. Okay, so this is how simply a PV system simulation is done. In the next session, I'm going to tell you about how to fine tune, how to become an expert in PVCs, how to fine tune. What expert guys are doing in PVCs? If this is very simple, then how come not everybody become the expert, right? So we will talk about how to fine tune the PVCs thing. Okay, we will open the same PVCs again later on, and then we'll discuss about it. Okay, thank you very much.